All right, everybody, welcome back. Unit 6, Lesson 3. Now, we're going to be continuing with the Pythagorean theorem, but this time we're going to put it on a coordinate plane. And once you put it on the coordinate plane, you can replace your a squared plus b squared equals c squared. You'll see that once we put it on the coordinate plane somewhere, we will have be finding the distance, the diagonal distance in space. So we have this right triangle here, and of course we start with labeling it. How do we label it? We always start with a capital C at the right angle, making this little c. Then the shortest leg is going to be A. That'll be capital A. Lowercase b, capital B. Now when we put it in space, this will have a location. X1, Y1 we'll call it. And this one will have another location, X2, comma, Y2. And then once we have that situation, we can then replace and find these distances, because we know that this leg of B is horizontal, right? This is a horizontal. So that means that if we subtract x2 minus x1, that'll give us the horizontal distance, and that's B. So we're going to replace B with x2 minus x1. And A here, that's the vertical. This is the vertical. So what did we do for vertical? We want to have the y coordinates, y2 minus y1. So we're going to be replacing A and B here with these numbers. So we end up with, if I can just go over here, in place of A, we're going to have y2 minus y1 squared, and then we'll have x2 minus x1 squared, and that will equal c squared. The distance here. So we know we have to take the square root to find c, and that's how we end up with the distance formula. So the distance formula. So then what you end up doing is replacing the letter C with D, and you can have it here. So in place of, we'll just call it D for distance. So this is your distance formula. You subtract the x coordinates, x2 minus x1. You square that, and then you subtract these and square that. Notice this becomes so important. Order of operations is so important in this situation. So it's Pemdas, and we're really focusing on doing the parentheses first. So that's how you can do the subtraction before you do this exponent right here. So you do parentheses, you got to do the subtraction first. It's always good, instead of trying to enter the whole thing into your calculator, it's very difficult to do that, to enter all of this at the same time. So I would suggest doing the subtraction first. Get that number, do that subtraction, get that number. Then you could do the squaring, and then you can do the adding, because then eventually you'll add them and then take the square root. The square root is also a parentheses, essentially. It's a grouping symbol. And here's a visual model of what we just talked about. So this distance here is y2 minus y1. And this distance here, so it's just this leg and a leg. So you're still doing the legs of the right triangle. And this is x2 minus x1. So very important here. This is your horizontal, is the difference in the x coordinates. So when you want a horizontal distance, the x's tell you left and right. The x's are left and right numbers. The y's are up and down numbers. So vertical, change. Change would be a triangle. Horizontal, change. The symbol triangle or delta is for change. All right, so we have some examples here. We have graph the ordered pairs, 3, 0, and 7, -5. You can see them here. Now you can, if they're on a coordinate plane, you can just count vertical 5, and you can count your horizontal 4. So it's, if you can do that, that's super. 1, 3, -2, +4. If I draw this triangle here, I can count the vertical distance, and I can count 1, 2, 3. So I can find by the Pythagorean theorem and not have to use the distance formula if I draw it first. So I don't know that. There's my right angle. This is C. I use a squared plus b squared equals c squared. 1 squared plus 3 squared equals c squared. Okay, so what is 1 squared plus 3 squared? It's 1 plus 9 equals c squared. 10 equals c squared. Then at the end, you take the square root. Remember, you're not dividing by 2, you're taking the square root. Because the square root of c squared is c. And then you have to figure out what the square root of 10 is. Square root of 10 is 3.16. So we'll just go to the nearest tenth. 3.2. So that's finding the distance on the coordinate plane by drawing it. If you want to make your life even easier, you can use the distance formula. So you wouldn't have to draw it out. Let's take a look here. Distance formula, step-by-step instructions. Let's see if I can get this just a little clearer. That's not much better, but here's our step-by-step instructions. Find the endpoints of the line segment. Okay, we found them there. We have the distance formula. It says we need to label the coordinates. One endpoint is x1, y1, and the other is x2, y2. So point A is at 1, 5. Point B is at 6, 2. Label x1, y1, your first pair of x's and y's. x2, y2, your second pair of x's and y's. Okay, so we want to find the distance here. And we're going to use the distance formula. And we're just going to substitute everything in. So we go with d equals square root. Substitute your values into the correct location. You will substitute 4 values, x1, y1, and x2, y2. Use parentheses when you substitute. So here's our parentheses. x2 is 2. I'm sorry, it's 6. 6 minus 1 squared plus, now I'm going to do the y's, 2 minus 5 squared. So we have that all set up. Now we're going to use Pemdas. So we go parentheses on the inside before I do any squaring. So I'm not going to use my calculator yet. I'm just going to do this simple 6 minus 1. I'll keep the parentheses 5 squared. Now I'm going to do these parentheses here. 2 minus 5, -3 squared. And now these squarings are pretty easy, so I'm not going to use my calculator yet. 5 squared is what? 25. Now this is -3 times -3, which is +9. So I end up with 25 plus 9. So that's a key location. Note that this is negative 3 times negative 3 equals positive 9. Two negatives multiplying make a positive 9. Really important that you don't mess this up. Anyway, we get D. Again, now we can add these together. 34. So we go here to our equation.
All MTech students, please report to the bus loading zone. All MTech students, please report to the bus loading zone.
And we end up with our solution 5.8. The square root of 34 is 5.8. Now it says check your solution for reasonableness. Now let's take a look at this leg over here. Is 3. And this leg is 1, 2, 3, 4, 5. And now D is 5.8, so it's very reasonable because it's the longest side and it's the hypotenuse of a right triangle. Okay. So with that, leaves you another problem right here to do on your own. Follow these step-by-step instructions. Right here, find the endpoints, label the endpoints, give the location of A and B, label them, then you're going to write down the distance formula and label them one pair x1, y1, the other x2, y2, just like we did in this situation. So you want to follow the example that you just did to do this one on your own, and then you're going to be turning that in. And you have a homework that you could also be working on. So good luck.